We are looking at exponential functions. And exponential functions are going to be functions where x is the exponent. So it's going to be in the form y equals a to b to the x plus c. And you're probably used to seeing that like this. We're going to have a new vocabulary word, asymptote. And that's going to be the line that our graph can never reach. So the asymptote is going to be represented with a dashed line, and our graph is going to look something like this. So it's going to go towards the dashed line, but it can't actually touch it. So it's going to just go towards that line. A is going to be the initial value. So that is what I start with. And we can find the y-intercept by adding a plus c. B is going to be the ratio that it is changing by. So if this is what, remember we were talking about things can double. So doubling means I multiply by 2 every time. Then my B would be equal to 2. And then the last thing we're going to have is that it's either going to be a growth, so it's going to end going up, or it's going to be decay where it ends going towards the asymptote. Okay, so what I've got here is I have a PowerPoint version of the worksheet that you have uploaded. So if you would like to, you can download that and go ahead and write these on there. But I'm going to go ahead and start with number 1. First things we're going to do is look for our asymptote, so C. And you can see here that there's nothing added on the end. That just means that our asymptote is going to be 0. So we're going to put our dashed line where y is equal to 0, aka the x-axis. Now we're going to go through and look at our a value. And you remember our a value is what it starts above the asymptote. So since this is 0, the amount above the asymptote would be 0 plus 5, which is 5. So I'm going to go up to 5 and put my very first point. Now we're going to need to work on getting the rest of the points. And to do that, what we're going to do is we are going to take the initial value and multiply by b. So b is 2. So my next point would be 5 times 2 is 10. I would add that to the asymptote, but the asymptote was 0, so 0 plus 10 is 10. So what I did is I moved forward 1, and then I went up to my new point. Now we're going to take that new point, we'll multiply it by the b value again. And my next point, so I go forward 1 again, is going to be 20. I can go the other direction. I'm just going to, instead of multiplying by 2, divide by 2, and it will get smaller and smaller. So what it's going to look like is it comes down through here and goes towards this asymptote. And that is our pretty exponential graph. We're going to do the same thing for number 2. We still do not have anything after it, so our asymptote is 0. We've got an initial value of 1/4. 1/4 is one of those fractions that's really easy to work with because it's like 1/4, and 1/4 is 25 cents. So I'm going to put a dot right where 1/4 would be, because it's 0 plus 25 cents, right? And now I'm going to start multiplying that by my rate of change, my ratio of change. So I see that it is multiplying by 2, so 0.25 times 2 would be 50 cents. 2/4 is 50 cents. Right. So the next one, I go over 1, and now I'm going up to 50 cents. I'm going to do the same thing. 50 cents times 2 is $1. So I go forward 1, and I go up to 1. And I keep multiplying by 2 because that is my ratio of change. And I keep going forward 1 and putting that new point. Let's do that one more time. What we had before was 2. We are multiplying it by 2, which gives us 4. So we move forward again once, and we're going up to 4. And draw that curve. And there's our second graph. Now feel free to pause this whenever you want if you want to try it ahead of me. Both of these graphs were growths. The next graphs we're going to look at are decays. And the way that I can tell that is by looking at my B value. And if my B value is bigger than 1, then I'm going to have a growth. If my B value is less than 1, or a fraction, right, a proper fraction, then I'm going to have a decay. And my graph is going to end up going towards the asymptote. So for both of these, our asymptote is still 0. I'm going to go ahead and put that on both of these since we can see that pretty easily. And then I'm going to move forward to number 3. So I can see that my initial value is 5. So I'm going to add that to my asymptote, and that's just 5, right? So I'm going to go ahead and put that on my y-axis. And now I'm going to take 5, and I'm going to multiply it by that rate of change, or that ratio of change. So it said 5 times 1/2. Now the reason this is decaying is because, remember, 5 times 1/2 is like 5 divided by 2. And $5 divided by 2 would be $2.50 a piece. So I'm going to go forward 1, and now instead of 5, I have 2.5. And I would do the same thing. If I have $2.50 and I multiply it by a half, or I cut it in half, I get $1.25. So I'm going to go forward 1, and then I have $1.25. I can take my graph and make it go through my points. And as you can see, this graph is going towards the asymptote as x gets bigger. So x always gets bigger in this direction, right? So if x is getting bigger, y is getting smaller. That is why this is called a decay. Same thing's going to happen over here with this 1/2. So let's go ahead and start this one, and this would be a good time to pause this and try it on yours if you're following along. So we can say this initial value is 3. The asymptote was 0, so we're just going to go up 3. And we're going to work on cutting this in half. So 3 times 1/2. $3 divided by 2 would be $1.50 each. So I need to go forward 1, up 1.5. Now I have $1.02. If I cut that in half, each of us gets 75 cents. So I go forward again, and I have 75 cents. And I'm going to connect my dots, remembering that it goes towards the asymptote, and it looks like it touches the asymptote, but it can't actually do it. there is my graph. So these look a lot alike. What I'm going to have to look for when I'm actually checking these is to make sure they go through the points that we just found, okay? And these were once again called decays because they end going towards the graph, whereas these were called growths because they end up going away from it. I'm going to look at number 6. Number 5 has a fraction and as the initial value. That is not something we're going to deal with on IXL, but we could see in the future. We're going to go ahead and look at number 6 right now. My asymptote is -1, which means that I'm going to go down 1 and draw my dashed line there. I'm going to look at my initial value. It says that it's 5 above -1. So 5 minus 1 is equal to 4. Or we can just count up. So 1, 2, 3, 4, 5. As you can see, that goes through 4. Or you can just count up 5 from the asymptote. And now we're going to go through the process of multiplying 5, our initial value, times 2, our ratio of change. And we see the next point is going to be 10 above the asymptote. So I can go forward 1, and I'm going to have to count 10 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now my other option would have been to add or subtract the asymptote. So I could have said -1, and that would have equaled 9. And that would have saved me from counting up to 9. But either way gives you the same answer. We're going to go ahead and go through the next one. We actually need to use 9 instead of 10 since that was our point. So we're going to say 9 times 2 is equal to 18. So that would be 18 above this. Or we can subtract 1. And we see that our answer is 17. So that is where our next point would be, is at 17. So once again, I went over 1, up. And we're going to go ahead and connect the dots through here. Go towards the asymptote. And I can check and make sure, should this be a growth? Yes, 2 is bigger than 1. Is my asymptote -1? Yes. And am I going through 5 above? So 1, 2, 3, 4, 5. Yes, I am, right there. Nice job. Last thing we're going to look at is if I have a negative number in the front. If I have a negative number, that means that it's going to open down, just like a negative on a quadratic meant I was going to open down. And this 1/2 still means decay. So let's go ahead and look through this. We do not have an asymptote, so that means it's going to be 0. We know that it starts at -4. So we're going to put a dot there. And then we know that we're going to be multiplying by 1/2. So -4 times 1/2 is -2. So I move forward 1 and I go down 2. And I'm going to do the same thing. -2 times 1/2 is equal to -1. So I go forward again, go down 1. And it is going to end going towards the asymptote. Anytime I have a fraction, it ends going towards the asymptote. And I'm going to explain a little bit more in a second video, but this should help you understand how to actually graph.